Hello everyone, my name is Tony. Today I will report a paper. It is about chemical analysis method, assessment and improvement of the sea ice processing for dissolved inorganic carbon analysis. Introduction. When sea ice forms, most of the brine is expelled to the under ice seawater due to gravity drainage, while a small portion stays trapped in the ice. But not only the brine, but also the gaseous carbon dioxide stay trapped in the ice. And compared to brine, the impact of gaseous carbon dioxide is on DIC measurement is greater. And what is brine? Brine is a high concentration solution of salt in water. And this is brine water, and this is seawater. And the ice atmospheric carbon dioxide flux is limited by the DIC star in sea ice. Improved measurement of DIC in sea ice are needed to better understand the air ice carbon dioxide flux. In addition to the impact of gaseous carbon dioxide, there are two supernumerary factors related to DIC measurement. What is supernumerary? Supernumerary is also mean extra or additional, and one is biological activity. Another is IKA. What is IKA? IKA is a minor, which normally forms in cold environment or in under high pressure. And biological activity. It is a common concern in DIC measurement and in melting ice water, which could convert organic carbon into DIC. And IKA is ubiquitous in sea ice and affect DIC analysis. During the process of melting ice, IKA crystal will also dissolve and change the measurement of DIC. And the purpose. Before the paper, the conventional method of sea ice processing is always time-consuming and inconvenient. However, the researcher modified it and tested it, and they wish the modified method of sea ice processing can be used conveniently in other experiment methods. Before we do the experiment, we need some sea ice sample, and the ice sample in this study used in this study were collected at Sea Ice Environmental Research Facility (SEIF) at the University of Manitoba, and it contained artificial seawater, and the entire pool was mixed by some pumps in order to allow the seawater carbonate system to reach balance with the atmosphere. After we get the sea ice sample, two methods were used to process the sea ice sample for DIC analysis. One is conventional method, another is modified method. Conventional method, first it put the ice core in a gas-tight plastic bag. The bag was sealed by an import sealer, and the air in the bag was evacuated gently by a syringe, and it cost several minutes to finish. The modified method, it placed the ice core in a commercially available plastic bag and then seal it by a vacuum sealer, just like this picture, and just call seconds. In order to test whether DIC will be loose during the application of the vacuum, they push the testing condition to the extreme when sea ice has the maximum permeability. In other words, the temperature of the sea ice core sample was brought as close as to the freezing point. After ice sample processing, after the ice temperature reached the desired value, -2 degrees Celsius, which was tracked by transport digital thermometer. And those ice cores were cut into two halves. One half was used the conventional method. The other half was used the modified method. After all the ice samples were sealed in a cold room, they were melted at room temperature and in the dark. And those water samples was measured directly after transfer to gas-tight vials. And this is another experiment we do to test the modified method. DIC storage in new bag in a percent and a percent of H3CO2. Two freshly collected ice core, and both of them were cut into halves. They all use a modified method, and the one ice core was sealed in pre-poison bag, which has 0.1% H3CO2, and the other ice core was sealed without adding H3CO2. And the time series measurement was performed on 21 days. After all the experiments were done, there were 4 data we need to measure: DIC, DOC, TA, and PCO2. DIC was measured by acidification with H3PO4 and detect the released carbon dioxide with a carbon dioxide detector. And the concentration of dissolved organic carbon, DOC, was measured with this machine. And the totally organology, TA, was measured by the grain titration method. 12 milliliter of the sample was titrated with 0.05 mole HCl. And PCO2 was calculated from DIC and TA using CO2SYS software. Assessment and discussion. Comparison between two methods. Due to the high degree of heterogeneity, the nature of the ice sample that was cut in half is different. So in order to make the DIC data from two methods comparable, DIC value was normalized to reference salinity, NDIC. And look at this table, and 1 is the conventional method, and 2 is the modified method. And the delta NDIC is the difference of NDIC between 1 and 2. And look at the figure, the x-axis is ice sample, the y-axis is the delta NDIC, and we can find that the means of this sample is zero. So two methods of placing the sample did not cause a large difference. Therefore, we can speculate that there is no loss of DIC during the process of venting the air. This is the second experiment we do to. There were two figures to explain the result. This is a Poisson sample, Poisson ice sample, and the figure X is day, the Y is the concentration of DIC, and we can find that during the 21 days, the DIC has no obvious change. This is an unpoisoned ice sample, and the x-axis is day, the y-axis is the concentration of DIC. And we can find that DIC did not change significantly in the first 3 days. But after the 3rd days, the concentration of DIC gradually increased. The DOC is the 3rd data we measured, and we can find that during the 21 days, the concentration of DOC is increased, and because of the releasing from the plastic vacuum bag, whose material is made of organic carbon. Whether the bag can pass carbon dioxide, and if the bag can pass the carbon dioxide, the concentration of DIC will increase. Look at this figure. The figure X is day, the Y is concentration of DIC. And look at the TP sample. TP sample is the top Poisson sample. And we can find that the concentration of DIC did not increase during the 21 days. So we can know that there will be no exchange of carbon dioxide in modified method. Effect of biological activity on DIC measurement. Some researchers added the H3CO2 to inhibit biological activity. However, in their research show that for the unpoisoned sample, DIC can stay unchanged for at least 3 days. An effect of gaseous carbon dioxide on DIC measurement. Under extremely condition. It can be known from calculation for length. The DIC difference will be small, so the effect of gaseous carbon dioxide on DIC will be smaller in common condition. Effect of IKA dissolution on DIC measurement. It is possible to quantify the contribution of IKA to DIC analysis by measuring the difference in DIC or TA. The concentration of IKA in the rest of the ice core was lower than the measurement uncertainty. Conclusion. No loss of DIC during the process of venting the air between conventional method and modified method, just like this video. It is not necessary to be poisoned unless high biological activity. And for new bags used in the modified method, there has no carbon dioxide penetrating. And the effect of gaseous carbon dioxide, biological activity, and IKA dissolution on DIC is also small. And the modified method will improve our understanding of the exchange of carbon dioxide across the ocean, sea ice, and atmosphere interface. And thanks for your attention.